Hey guys, in this video I'm going to walk through this Leetcode number 445, adding two numbers, and this is the second version of the question. So this question was asked by Amazon, um, Microsoft, and other Apple and Bloomberg, Facebook, and Samsung. As you can see, so Amazon loves this question. Let's dive into the question. So we are given a two linked list. For example, the first one 7, and the next one links to 2, which links to 4, which links to 3, and this one is representing the number 7,243. And then they have another linked list, which is 5 links to 6, which links to 4, and this number representing this linked list is representing 564. So, and then these two numbers together, and then we're getting 7,807. And we have to return another linked list that has the head being 7, which links to 8, and then links to 0, and links to 7. So the difference between this version and the first version of the question was that in the first question it was a bit easier because all the linked list is in the reverse order, and now is in this order, which is a little bit difficult to deal with. But let's dive into the solution. If you haven't tried the first version, I suggest you to take a look at that question first, because that one was really classic Leetcode question, and it's not that hard to do, and it doesn't take too much time, and also it builds a very good intuition to this question. So without further ado, so let's dive into the solution. So first, we need to have two stacks. The rule being stacks, as a reminder, being first in, last in, first out. So that's a stack, which is opposite of queue. And we have a function named push to stack. Basically, what it does is to pushing all the number to the stack. So, for example, when we traverse this linked list, and the 7 is the first number we are coming across, and then we'll push to the bottom of the stack, and then we put on top of it will be the number 2, and then the number 4, and then the number 3. So basically, number 3 which is on the very top of the stack, and then when we pop it off, and then this number will be the first number to be dealt with in the stack. And then I will do the same thing for the second linked list. That's why we create a function in here to avoid some repeated code. Okay. So imagine after these two functions in here, after these two calls of the function here, we will have two stacks, and then which collecting all the numbers from the first linked list and second linked list. And as just like most of the linked list problem, we need to have a dummy head, and I initialize the dummy head with a negative number, which is the it's just number that I think it's not possible to get it anywhere else. I just want to have a dummy number. I put it in -1 in here, and then we have the head and punch the dummy head, and also we have to manage the carry number when we do the addition. So while there's number in the stack, or there are numbers in stack number 2, or there's something in the carry, and then we assign the number the number from stack 1 to A. So if there's something in the stack number 1, and then we pop it off and assign to A, otherwise it's just 0. If there's nothing in stack 1, the number will be 0. Do the same thing for stack 2, and then we assign the number to be B. So we have the temporary sum, which is A plus B plus something that is carry from the prior calculation. So for example, the temp sum number 1 will be 7. Right? The first one we call this one will be variable will be 7, because 3 plus 4 and the next one will be 10 because it's 4 plus 6. And then we take the modular and also take the floor duration, and then extract the modular and also the carry. So which will be used in the next calculation, and then modular will be used the current calculation. So we create a new linked list and assign the modular to it, and then connect to the temporary linked list that we just created it. And then this one we move the linked list by using head equals to head dot next, and to deal with the situation where it's not the same length, so that's why we use the or. Also, we need to consider the case where if the carry has some number, but none of these two stacks has number, so we have to still deal with that situation, the scenario. So that's why we use or to connect the stack 1, stack 2, and carry. So let's run that. As you can see, it's not the right solution. So the correct answer should be 7,807. However, our solution is 7,087. And if you pay attention to it, a closer attention to it, you can see the correct solution is a reverse of the solution that we are having. And the reason being, when we do the addition, for example, 7 plus 3, and then 6 plus 4, and then we assign to the first number in the linked list, which is 7 here, and then the second number, which is 10, 10 and the modular of 10 will be 0, and then assign to the second number. So, but that number should have been in the reverse order, right? It should be, so for example, this number should be here, this number should be here, because when we do the addition, we take the last number in the input list, and as you can notice, we have to reverse the linked list. So let's do that. So in here, we just implement the reversing linked list section. I'm gonna briefly go through it. It's pretty straightforward. As you can see, so we getting the real head by calling dump head.next, and then we have the current, and then assign it to the current head that we're looking at. Also, the previous will be none because the first so the last elements, the last element of the linked list, the next one will be none. So that's why we have the previous equal to none in here, and it'll make a little bit more sense when I go through the while loop. So the next one, so we just want to save the next one by assigning it to the current.next, and then this is where we do the reassignment. So current.next equals to previous, and in a special case where for the first element, which will be the last element after we reverse it, for the last element, the next one will be none. That's why we assign this period equals to none in here, just a special case. And then for the next one onward, and the next one will always be equal to the previous one. And this is how we do the reassignment to change the direction of the linked list. And then we move forward, and when we keep doing the reassignment, and before we doing the reassignment, we have to keep moving forward. So the previous one will be equal to the current one, and then the current one will go to the next one. And let's run that, and this one works. Okay, as you can see, it works out and looks okay. So let's look at the time complexity. So the official solution says it's big of n1 plus n2, or where n1 plus n2 is the number of elements on both of the lists. So let's understand why that's the case. So we first push in the number to the stack, and actually we do that 2 times in here. So that's already big of n1 plus n2. And then we do the addition, and this is another n1 plus n2, as we can see. Oh, sorry, this is not n1 plus n2. It's gonna be the maximum of n1 plus n1 and n2, right? And this while loop just loop through, iterate maximum of n1 and n2 times, and then this while loop in here, uh, it is also the maximum n1 and n2. But the most time consuming component will be here. So that's why it takes the big O of n1 plus. So for space complexity, it says big O of 1 space complexity without taking output list into account, and a big O of n maximum of n1 and n2 to store the output list. So essentially, it's saying the stack number 1 and stack number 2, and in this case, it's taking a big O of n. In my case, maybe slightly different than the official solution. It would be a big O of n1 plus n2 because we're taking 2 stacks, and then we also have the another linked list to save the result, and that takes a big of a maximum of n1 and n2 space complexity. So yeah, so this is my solution. I hope this is helpful. If it is, please like and subscribe. That will be huge support, and I will see you in the next video. Thank you so much for watching. I will see you next time.